Hello everyone, welcome back to my channel, and today is the 8th of 100 days of DevOps, and over the next couple of days we are going to be considering a critical part of tech that everyone needs to understand and be very good at. Even if you're a DevOps engineer, a cloud engineer, a cybersecurity specialist, it's something that everybody has to know, and that is networking. So networking is something that we will do over the next couple of days. And if you've been following, or if you've not really, if you're coming across this video for the first time, so we've previously covered about 7 days of Linux fundamentals, because what we are trying to do is that we are trying to build the core foundations, and then we'll take it one step at a time. So each concept, each knowledge is layered on the understanding of what we've learned previously. So I would implore that you do not skip to this particular video, but you also try and look into the other videos. And if you're yet to subscribe to my channel, I would also implore that you do well to subscribe to my channel, and most importantly, turn on your notification bell so that you get updated whenever I upload any new videos. And if you know anyone who is actually trying to get into tech, and they have not yet decided on what he or she wants to do, or you have somebody who has said, okay, I think DevOps is something that I would like to also go into, you can also refer the person back to this channel, so that they can follow me as I talk about a lot of these things. And I hope that maybe by the time we are done with the 100 days of DevOps, we would have been able to impact ourselves, and we would have been able to gain more knowledge to what we know already. So let's head straight down to the business of today. So today I'm not going to be working on the terminal. We're not going to do anything on the terminal, because I believe that before we start typing commands, before we start writing scripts, before we start doing anything, it's very good that we understand how everything works under the hood. Let's understand the concept of why exactly are we doing this thing, what exactly are we supposed to do with it, how does it actually work. So we need to understand how everything works together, how everything comes in together and combines to give us that achievement that we want to achieve. So what exactly is networking? That's where I'm going to start from. What exactly is networking? So I'm just going to be very basic in my definition. So networking is to me networking is ways in which different components of a system communicate with each other just to achieve a certain goal or a request that has been made. So two components of a system will not be able to work together if there is no communication between them. And what actually facilitates this communication is your networking configuration. So if your networking configuration is done perfectly between two components in the system, they are going to communicate effectively, and you will get the best result, the best outcome, which you want it to get. So that's basically a quick overview of what networking is. And we're going to be doing this over the next today and tomorrow. So I've split it into two parts. Today we're going to cover a part which is IP addresses, subnet, CIDR, which is CIDR, and ports. Why tomorrow I've dedicated tomorrow just for understanding the OSI model and TCP/IP, how everything works when you type, when you make a request, how everything goes down to the server, and how you get a response back. So like I said, today we'll cover IP addresses, subnet, CIDR, and ports. So let's go straight to the first concept, which is IP addresses. So what exactly is IP addresses? Or what exactly is an IP address? So let's abstract the IP to one side and focus on the address for a few moments. So IP basically means internet protocol. So but I'll focus basically on the address. So what exactly is an address? Everybody knows what an address is. If you're watching this video, I want to believe you know what an address is. When you order something from, say, Jumia, or from Walmart, or from Amazon, or from any of these online stores, one of the things that you need to fill out, apart from your name and the rest, is your address. Because without that address, every other detail you filled out is basically of little use to them, because the point of ordering things is so that it can be sent across to you. So the only way for those things to be shipped or to be gotten across to you is through your IP, your address. So address basically is like a location that you can be reached on. So let's move that back, or let's translate it back to the concept of IP address. So IP address is like a unique identifier. Like I said, no two buildings can have the same address. It's either your number 4 of this certain street, and your next building is number 5, and the next building is number 6. You cannot see two buildings in different compounds having the same address. You cannot have two number 4s of the same street. So it has to do with a unique identification. So it's like a unique identification for your devices, your smartphones, your PCs, your smartwatches, and everything. It's like a unique identifier that helps anyone over the internet to locate your device. So it's used to communicate over the internet. And I got this quick definition from Fortinet. So an IP address is the unique identifying number assigned to every device connected to the internet. So your device A will not be able to communicate with your device B if your device B does not have an IP address and an internet access. So basically that is the quick definition of an IP address. So I'll give you an illustration. Say you have a building and you have about 4 devices in the building connected to a Wi-Fi, and one of the devices makes a payment through a payment platform, and you want to track which device actually made that payment. How do you go about that? You go and you do your findings and you narrow it down to the IP address, because when you check the details of that payment, it's definitely going to show the source IP address. There's something called source IP address and destination IP address. Source IP address is where the request is coming from. Destination IP address is where the request is going to. So when you check your source IP address, you would see the particular IP address of that device. Then you now go and search which device actually owns this IP address, and then you're able to get the particular device that has made that payment. Or you walk into, or you've been in situations where I have been in situations where in a family, the kids' devices are restricted to, let's say, to platforms like Instagram. So they don't allow the kids' devices to have access to a platform like Instagram. So how did they do that? Sorry. How did they do that? They just block access to that particular IP address that is embedded in the device of that particular kid. So those are some of the things that you can do with IP addresses. Those are some of the things that IP addresses enables us to do. It's just a unique identifier. So no two devices can have the same IP address, like the same IP address. No two devices can have the same IP address. IP address can change from time to time depending on the location, because sometimes IP address can be static, sometimes it can be dynamic. So it's possible for you to change depending on your location that you are. However, in that same location, no two devices can have the same IP address. It's just same thing like a house address. If you go to this street will definitely have house number 1, 2, 3, 4. If you go to the second street will also have 1, 2, 3, 4. So both streets have houses 1, 2, 3, 4. But in a single street, you cannot have 2 houses 1, or 2 houses 4, or 2 houses 10. So that's basically the whole concept of IP address. So it's just a unique identifier that is assigned to all of our devices, which can be used to connect or communicate with device over the internet. So I believe I've given a good introduction to IP address. And we have 2 kinds of IP address. We have IPv4, IPv6. So basically it's just IP version 4, IP version 6. So and the most used one is the IPv4, because I think it's in terms of simplicity, it's more simpler. Though I'm not sure, but I think when it comes to security reasons, I don't know. I think IPv6 version 6 is more secure, but in terms of simplicity and adoption, so I think IPv4 is widely adopted than IPv6. They're still working on adopting IPv6, though some organizations, some companies, some persons are already using IPv6, but most commonly you would see an IPv4. And how do you know the difference between an IPv4 and an IPv6? So you can see for here it has 192.168.5.18. It is a numeric dot decimal location. So while for IPv6 it's alphanumeric hexadecimal notation. So that's the difference. And IPv4 has 32 bits, IPv6 has 128 bits. So for this particular part of our learning, since IPv4 is the most widely used, we are going to be sticking with IPv4. So if you're seeing this for the first time, or if not, you must have seen things like IP address of like 192.168.27.5 and stuff like this. So, and if you don't really understand how these numbers came about, so I'm just going to do a quick breakdown or a brief breakdown of the whole concept of all these numbers. How are these numbers coming about? Where are we getting these numbers from? I don't like you're not really understanding how everything comes together. Just stick with me while I explain, and hopefully you understand by the end of my talks. So now let's take one of the IP addresses. So like I said, basically this is the format of IPv4. You will see a number then separated by a dot, 192.168.27.5. So why 192? Why 168? Why not numbers like 500 or 600 or 700 and stuff like that? So in a particular, I call this for this number here, it's the highest number you can have per number before, like per, will I say, I want to call the name, but I want to wait a bit before I call it. But regardless, highest number you can have per each part of this IP address. Let's just say this IP address is divided into 4 parts. So per part of this IP address, the highest number you can have is 255. So it ranges from 0 to 255. So you can see it goes that way, 0 to 255, 0 to 255, and 0 to 255. So if you see that all these numbers fall within that range of 0 and 255. As well, if you check to your left hand side where my mouse is, you can see that all the numbers that I've stated here ranges from 0 to 255. So now let's now go deep into how these numbers came about. So like I said, IPv4 is comprises of 32 bits. But why 32 bits? Where did that even come about? Let's go back a bit and understand. Let's go a little bit into machine language. Now we see these numbers 192, 168, 27, 5. These are numbers that you and I as humans can actually understand. But our computers only understands zeros and ones. So computer understands just zeros and ones. Computer does not understand what is 192 or what is 27. It is those zeros and ones that the computer converts to these numbers that you and I can actually read. Because if we say we as human beings should be cramming the zeros and ones, it's going to be too much for our brain to actually carry. So that's why it was converted in a way that we can understand. So computers understand zeros and ones, so bits and byte. So per octet, this is 1 2 3 4 5 6 7 8. 8 is actually octet. So this particular number represents 1 octet. That's because, why is it 1 octet? That's because there are 8 bits rather per octet. So an 8 bit is equivalent to 1 byte. So if I'm to sum this up, IPv4 has 4 bytes, which is 4 octets, and each byte has 8 bits. So since each byte has 8 bits and we have 8 bits per byte, and we have 4 bytes. If we calculate it together, that is what gives us the whole 32 bits. So that is where the 32 bit is actually coming from. That's because of we have to convert these numbers to bits and bytes and the rest, just to understand how computer interprets all these numbers. So I believe that that wasn't too confusing. Each octet has 8 bits. There are 4 octets of 4 bytes, and if you multiply it, if you add up all these 8 bits together, you have 32 bits. So this is what is shown there. 4 bytes or 32 bits. 1 byte is equals to 8 bits, and each octet is separated by a dot. So that is basically the format of IPv4. So going forward, once you see something like this, you already know that this is an IPv4. It's an IP address, and it is an IPv4 type of IP address, not an IPv6. So now we said this is each number contains 0 to 255. Then if we calculate what's the highest number that can be, or what's the highest number of IP addresses that can be in an octet. So the highest number of IP addresses per octet is 256. So that's the total number of IP addresses that can be in an octet is 256. But you would want to ask, okay, Sam, you said the highest number is 0 to 255. So now why are you saying total number is 256? Remember that we are counting from 0 and not from 1. If we were counting from 1, we'll have 255. However, since we are counting from 0, we need to include the 0, and it is that 0 that makes it 256. So because now 8 bits, if you do 2 raised to power, total number of bits here, 2 raised to power 8 is 256. So that's let it not confuse us. It's just we are starting our count from 0 and not from 1. That's why you have 0 to 255, and that's why you can't see, even though total number is 256, you can't see an IP address that has 256. It's always ending with 255 because we are starting from 0. That's why you can see this 10.0.0.1 because 0 is included. We're not starting our count from 1. We're starting our count from 0. So don't be confused, don't get confused. Total number of IP address per octet is still 256. However, in terms of range, it's from 0 to 255. So let's do a little bit of practical here, because you might be wondering, how did we get 192? What did we add? What did we subtract? What did you cut out to have 192, or to have 168, or to have 27, and to have 5? So let's do a little bit of calculation. So let's break this down. So we have 192.168.27.5, and I've done well to put those bits here. So now, how did we even arrive at 256 in the first place? That's 255 in the first place. So if we do this, let's say, since computer understands 1 and 0, so let's assume that all these numbers are 1. Let's assume that all the numbers are 1. So we have 1 times 2 raised to power 0. Like I said, we start counting from 0. That is, if you are familiar with computer science, you should know that in computer science, or computer as a whole, when you're dealing with computers, you start your count from 0 and not from 1. 0 is a valid number when it comes to computer science. So you don't start your count from 0, you start your count from 1. So you have 1 times 2 raised to power 0, 1 times 2 raised to power 1, 1 times 2 raised to power 2, down to 1 times 2 raised to power 7. And it's ending at 7 because we're starting from 0. Remember, whatever number you remove 1 from it, if there are 8 ones here, you remove 1 from it because you're not starting from 1, you're starting from 0. I know I'm repeating this a lot so that it gets stored in our memory that whenever we are counting from 0. So if this is a concept that is, if it's entirely new to you, so just stick with me while we get all this everything sorted out. So we start with 2 raised to power 1. So 1 times 2 raised to power 1 is 1. 1 times 2 raised to power 2 is 1 times 2 raised to power 0 is 1. 1 times 2 raised to power 1 is 2. 1 times 2 raised to power 2 is 4. 1 times 2 raised to power 3 is 8. 1 times 2 raised to power 4 is 16. So 1 times 2 raised to power 5 is 32. 1 times 2 raised to power 6 is 64. And 1 times 2 raised to power 7 is 128. So basically, this is how the calculation is. So now, how did we get 192? So I'm going to draw another text box here, and I'm going to copy what I have here. Sorry. I'm going to copy what I have here and also paste it here. So now, how did we arrive at 192? So we are going to change all this one. So where the change is going to happen is the ones. So I'm going to change this to, if we do 128 plus 1 plus 64, we actually have 192. So what we do is that we change all these ones to 0, change it to 0, we change it to 0, change it to 0, so we change it to 0, so we change it to 0. So basically, I'm going to copy this. So 192 is actually represented. This is how your computer sees 192. So it sees it as 110000000. So this is 192 in computer language. So this is how your computer has interpreted 192. So if you type out 192, if you convert this 192 to computer language, you're going to get 11000. So if you want to do for 168, I would copy also this, and so if we are doing 168, so let's calculate. If 124 plus 192 plus 64 gives us 192, we need that means this is already 0 because it's not going to work. So we'll do 128 plus 32. That is 1. This is 128 plus 32. This is this should be like 160. So we already have 160. Then we need 8. We need 8. So 16 is bigger than 8. We delete it and replace with 0. We need 8. 8 is already here. We would delete this and replace it with 0. Delete this, I place it with 0. Delete this, I place it with 0. So everything, of course, everything multiplied by 0 is definitely 0. So 128 plus 32 is 160. 160 plus 8 is 168. So your computer interpreted 168 as 1010100. So this is how your computer interpreted. Let me put this. Let me change this to 1. Okay. So this is how your computer interpreted 168 as. So let's move to, let me shift this a bit. Let's move to 27. There are actually applications, online applications that will help you calculate all this, but I just feel that it's something that I really need to touch on. I really need to drive home so that even without relying on the calculator, you can use the calculator when you already understand the fundamental, when you already understand what you're supposed to do. So that's when you can say, okay, you want to now get external help, you want to get external things to calculate. In an ideal environment, nobody will actually ask you to sit down and start converting this octet down to binary and everything. But for the purpose of this particular part of our learning, I feel it is important that we need to actually understand exactly how all these things came about, so it doesn't look strange to us, or it doesn't look like French to us. So now let's get 27. How do we get 27? Let's say if we do 1 plus 2, 1 plus 2 is 3, 3 plus 4, 3 plus 4 is 7, 7 plus 8 is 15, 15 plus 6 is more than 27. It's more than 27. So what we need is between this place and this place. That means we have no business with all this one. So I can change all of this to 0. I can change all of this to 0, and can change all of this to 0. So all these ones are 0 already. So let's start now. Let's start with 16 up. To get 27, 16 plus 8 is what? 16 plus 8 is 24. If I'm correct, yes, 16 plus 8 is 24. So 27 minus 24 is 3. We need 3 more. So and we have 4 here. So automatically this becomes 0. So we have 2 and 1, which gives us 127. So your computer has interpreted 127 as that's interpreted 27 as 0001111. So this number is what results to 27 in your computer. We see it as 27, but your computer sees it as 0001111. And then finally, the simplest of all, 5. So we're looking for 5. Basically, we should know that 5 is 4 and 1. There is no 3. If there was 3, it would have been 3 and 2. So we should know that 5 is 4 and 1. And we already have 4 here. We have 1 here. So we change all of these to 0. We change all of these to 0 and 0 and 0, 0, and finally 0. So your computer has interpreted 5 as 0000101. So basically this is how your computer interprets all these numbers. So basically I just needed to quickly explain this so that we'll know what actually works under the hood, how all these numbers come about, so that when anybody asks you, if you go outside and they ask you, okay, how did all these numbers come about, you're able to properly explain how all these numbers came about, and even be able to show them, okay, that at least you know your stuff and you know what you're doing. You know that the total number of IP address that can be in a particular octet is 256, while the range is from 0 to 255, and you have a clear understanding of IP addresses, how this number came about, and how your computer interprets it. So basically this is an overview of IP address. If there's anything I didn't cover, or if there's any part that you don't understand or you need more buttressing on, you can feel free to drop it in the comments. I will look into it and probably make a separate video for that, just to be able to explain those concepts well. So let's look at something else. Let me create a new slide. So let's say for example, this is an office space. This is an office environment, and an office environment, and let's say we have these persons. Okay, let me just copy this. So we have, these are workers in an office, and have like 5 workers in an office, and each person, because once you get to your office, most of us, each office basically connects to something like an office Wi-Fi. So let me put this also as the office Wi-Fi. So I'm going to put this as the office Wi-Fi, and everybody, once you get to your office, you connect to the office Wi-Fi to be able to do things in your office and all that. And let's now assume that this particular person, accesses let's say a malicious website. Maybe like I said, maybe a phishing link was sent to him or her, and then the person accesses the website, and the person's device gets hacked. Now once this hacker gets access to this particular device, because this device is connected to the office Wi-Fi, the person has access to all the devices in this particular office. And Of course, there are confidential information or there are confidential details such as the payroll of the salary of payroll of the staffs, HR information, the finance ins and outs of the organization and stuff. Where these are basically confidential information in which you don't want any hacker to get access to, and you want to actually secure this thing. So what do you do in such a situation? Now, this is where the concept of subnetting comes in. So what is subnetting? So subnetting is basically you pick your, it's just the way the name sounds. The way the name sounds. So subnet is like you're splitting, let's even split this. So sub and networking. So sub means like a smaller number, or a lower number, or a lower category of a larger network. So subnetting basically enables you to divide your network into smaller parts so that everybody does not have access to, or so that it is more secured and not accessible to everybody. So what does it do? Let me do this. I'm just going to draw a line here, and okay. So what have you done in this case now? Let me take this here. So let's say this particular network belongs to the finance team. Okay, so let's say this particular network belongs to the finance team, and just 2 persons are in the finance team. So now, if this hacker gets access to this person's device, he can be able to have access to all the other devices in this Wi-Fi because they are connected to the general Wi-Fi. That's the free Wi-Fi that anybody that comes in can use. However, the details in the finance team are very, very safe because now these 2 people are not connected to this device. They are connected to the finance device. So subnet is what enables us to be able to create different parts from the bigger, like from the bigger network. Let's say, for example, now if you're familiar with Amazon or AWS, there's something called VPC. So whenever you're creating your VPC, that's your virtual private cloud, or whenever you are creating your VNet in Azure, they will always ask you to include your subnet. So basically, you can say, for example, let me do this. Let's say your company requests for 65,000 IP addresses, and let's say we have 192 dot 25.0.0. So this particular IP address contains 65,000 usable IP addresses. How do I know that? Like I said, each component contains 256, or each octet contains 256. So if I go to my calculator here, and I just go to the standard calculator and I do 256 times 256. So when I do it, it's 65,536. So the more you work with these things, the more you can remember things on the top of your head, the more you're familiar with it. So let's say your company requests for 65,000 IP addresses, and out of that 65,000 IP addresses, the finance team wants, or you want to segregate 256 IP addresses. So let's make things a little bit simple. So let's say 256 IP address, you want to put that on a separate network. So now, what will you now do now? That means since we need 256 IP addresses, we're only working with the last octet, because from our calculations, one octet has 256 IP addresses. So what do you now do now? Since you have, let me get this. Bring it here. So since you have 32 bits here, and we are working with just the last bit. So you take like let me just use this. Like you strike a balance here, or you strike a segment here. So now these three parts of your IP address remains unchanged, can be constant. It can be constant. However, what will change is the last part. So if you calculate 8 plus 8 plus 8 is 24. So you're only working with the last 8. And that's why sometimes, I don't know if you've ever come across something, you have something like this, you now have dot 24. Yes, this is basically you're dividing your main IP address into subnet. So what actually enables us to divide that main IP address into subnet? But before that, I want to say something, and it's we have two types of subnet basically. We have the private subnet and we have the public subnet. The difference between the two is that private is private, it doesn't have access to the internet, while public is a subnet that has access to the internet. So that's basically the difference between the private and the public subnet. So let's go back to what actually helps us to, segment our IP address into different subnets. That is where the concept of CIDR comes into play. That's where the concept of CIDR comes into play. And let me put this here. CIDR, it's called CIDR. The full meaning is CIDR. The full meaning is classless interdomain routing. So what does it do? It just, if you want to create a subnet on, like I said, if you want to create a subnet on AWS or on Azure, you'll be asked to provide a CIDR range. So it's basically a way of showing how many IP addresses are available in a subnet. So how many IP addresses do you need? That's what is termed to be like the CIDR. So this last part, this /24, is what is actually the CIDR range. And what it's telling us is that, okay, the first 24 parts of your IP should remain constant. You're not touching that. But the last 8 can actually change. So I can now say, okay, let's say for example now we have let me change this to, okay, for example now this IP address now, like I said, this address contains 256 it contains 65,000 IP addresses, and then we need 256 IP address from that one. So what we can do is that from this one we can say, since our CIDR range is /24, we can allocate any IP address from 172.25. We can pick any number here, 3.0 to 255. So these 3 will remain the same. So it will be 127.25.3.0, 127.25.3.1, 127.25.3.2, down to 127.25.3.255. So you can decide to say, okay, what you want is .6. So, but what I'm trying to say is that the only place that will change is this last octet. So it will now range, is this part that will range from 0 to 255. So that's basically what CIDR helps us to do. It helps us to divide our subnet. So this is when you see things like this, when you see like a slash in front of it, you don't get to panic. It's just basically you've divided your big IP address into like a smaller IP address. Okay, I need so number of IP addresses. Then you now say, okay, you're dealing with so part of your octets. You understand? So, and it doesn't just work on, let's say, after each octet. So you can have, let's say for example now, instead of 256 IP addresses, your organization needs about let's say 8 IP addresses. So they just need 8 IP addresses. So this is going to be let's see, it's going to be, let me go back to this place. So this is 8. Trying to see if I can recollect it. So since if when you take out 1, this is 1, this is 2, this is 4, and that means 2 plus 3 plus 1, 4 plus 2 plus 1 is 7, which is less than 8. However, the next one is 16. 16 is greater than 8. So shift this here and put it here. So what we do is that we now say 32 minus 4. 32 minus 4 is 28. So this will be slash 28. So that's basically CIDR is just showing you, it's just used to calculate total number of IP address. So this I was able to come up with a formula for that, and the formula to get your CIDR is it's good for you to know all these things so that you just know how everything works. You understand? So in a real environment, in a production environment, no one is actually going to ask you to start calculating all this. There are already online applications for it. But let's say, for example, now you're now told, okay, you're a network engineer, or you're a DevOps engineer, or you're a cloud administrator, and someone comes to you and say, oh, this is the big network, this is our VPC. We need so number of IP addresses. So we need you to help us to carve out so number of IP addresses. If you don't understand the concept and how these things work, you will just be dumbfounded. You won't be able to do anything. So CIDR is equals to 32 minus smallest value of x, where I need to get this. Where 2 raised to power x is greater than or equal to n plus 2. So this might be a lot, and it might just be a lot, and if you're not really like a mathematics person, it might just be so much for you to understand. Basically, this is just a formula that you can use to calculate the CIDR range. So that's how I did it. I said, like, for example, now I needed 8 or I needed like 10 IP addresses. So the smallest value of x, where 2 raised to power x is greater than or equals to n plus 2. So if you do, like I said, I calculated this one 2 times. This is 1. This is, let me go here. This is 1. This is 2. This is 4. If you add these 3 together, it will give you 4, 5, 6, 7. But what you need is 8 or 10 IP addresses. So here, if you add it, if you do 7 plus 8, that's already 15. So it has exceeded the number of IP addresses, which is 10. But at least it's not lesser. So you just cut it off at this point. So you now minus 32 from whatever, minus 2 from this 4. So you have 28. So if someone comes now and say we need 4 IP addresses for us to use. So if you do 1 plus 2 is 3. 3 is not up to 4. But if you add 4 plus 3 is 7. 7 is more than 4, right? So you cut at this point and then you do 32 minus 3. So this one will change from /28 to /27. So that's basically how to calculate your CIDR range. You can always get all of this online. So it just helps you basically understand how you want to divide your network. So a quick recap of what I have said so far. We defined networking. We defined what networking is. We defined what IP addresses are. We talked extensively about IP addresses, how things work under the hood. And we also got into the concept of subnet, of which I stated the importance of subnet in our day-to-day activities, where subnet gives us security, privacy, and it helps us to be able to mitigate against cyber attack, that might want to come in through maybe a malicious website or a phishing website or anyway. So, and also related that to CIDR, which is responsible for us to which is a way of showing how many IP addresses are available, which helps us to be able to calculate. Let's say, for example, now somebody wants 10 IP addresses, somebody wants 56 IP addresses, and you can use that having the knowledge of CIDR, so you can be able to calculate how many IP addresses that you can get from a particular number. So, like I said, if it's too much for you to understand now, just take your time. You can watch the video over and over and over again, and you can Google, you can use your ChatGPT for it to break down if some of the things I've said are a little bit complex and not easily understood on the first time, and you feel like you need more breakdown to a more elementary way. You can go to ChatGPT, you can go to Google, you can go to whatever search engine or whatever AI that you're familiar with, and just read up on it and gain more understanding. The more you get knowledge on it, the more you're able to equip yourself to be able to work very well as a tech person in general. Because like I said, networking is one of the things that you just have to know, and you have to really know it and know it well, because now a lot of things now are migrating to the cloud, and when it comes to, if you're dealing with anything cloud, you need to be sound when it comes to network. So even in cybersecurity, you also need to be very, very good with networking. Some people are network engineers. When you have all this knowledge, you're able to go far in your career. So the last thing we are going to talk about is ports. So ports is actually very, 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 very easy. So I'm going to just delete all of these. I'm going to still use this to illustrate. Let me delete this, and let me delete this. So let's assume that delete this also. So when you walk into an apartment, you walk into a house, let's say a 5-bedroom flat. So now, before you go into each bedroom, you don't just walk and just find yourself in each bedroom. What do? You pass through the door. So that door is what gives you access to the bedroom, to that particular bedroom. So it's the same thing with ports. Port is like the door to an application. So let's say we have 1, 2, 3, 4, 5, 6. So we have 6 applications sitting on this server. How do we know which application we are talking to? So what we do is that we give them port numbers. So you can have different port numbers for different applications. Let's say your application runs on IP of let me see, use this 6.28. So this whole let me just make this better. So let me put this here. So let's say this is your application and it runs on IP of 172.255.6.28. This entire application, this is the IP address of, this entire server, this is the IP address of this server. So now, if you want to communicate with an application, let's say all these circles are applications on this server. If you want to communicate with an application on this particular server, how do you achieve that? Since the server has one big IP address. So what we do is that we attach ports to it, and the ports are usually represented by a dot, and then you add the port number. So let's say I can give one of them port 9000, that's port 9000. I can give the other one maybe I can give the other one 9190. It basically just assign various number. It's just like a differentiator. However, there are some port numbers that are already taken. So there are some port numbers that are already taken. So you can't assign such port numbers to your application. It's not going to work. For example, port number 80, port number 443, port number 3306, port number 8080, and the likes. You can, you can research for all these port number. You can't give your application port 22. It's not possible because that has already been taken already. So all these things are actually things that you need to know about. So that's why most times when you want to give a port number, we always advise that you start from, let's say, 9000, 9191, and the likes like that. So basically you can do that. So you can have you can go and Google search or research for the port numbers that have been taken, because I know that MySQL has a port number, Postgres has a port number, Jenkins has a port number, Redis has a port number, all of them like that has a port number. So you don't want to use a port number that has already been assigned to another application. So you have to use something different. You get? So, but that's the whole concept of ports. Port is just like a doorway to an application. It's what gives us access to an application sitting on a particular server. So I believe I've been able to an extent, do justice to explain what IP address is, what subnet is, what CIDR is, and what port is. Like I said, you can feel free, any questions, you can feel free to put your questions, or any part that you didn't understand, you can feel free to leave those leave any questions in the comments, and I'll be glad to explain, and if possible do a separate video on that. So that's all that we have for today. Like I said, tomorrow will be dedicated to understanding the OSI model and TCP IP. So that will be all from now. I just hope that you found this particular video helpful, and I hope that this has to an extent giving you more understanding of how networking works and how everything works under the hood. So I'll see you again tomorrow. Cheers.